Hey friends, so we're going to transition from just using those big number lines, the double number lines, into ratios with tables, which is really not that hard. Basically, we're going to take something that used to look like this, and now we're going to turn it into something that looks like this. Big difference, huh? Not really. So how many tiles will be in the fourth figure, the fifth figure, the 10th figure? So this is the first figure, this is the second figure, this is the third figure. I'm going to do this in table style instead of the diagram this time. This is the figure, and this is the tiles. So in the first one, I can just count, and it's 7. By the way, if you look at the blue, it's just doubling every time. Or they're adding another one, sorry. They're adding a new set of 4, and they're adding a new set of 3 every time. So each new block gets this plus this, so it's up 7. This one gets another one, so it's another up 7. So in the second one, 8, 9, 10, 11, 12, 13, 14. And the third one, there'd be 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Pretty simple. Now what we're going to look for is the ratio. So the ratio is 1 to 7. So one figure gives me 7 tiles. That's my big thing. There are a bunch of ways I can look at this visually. I'm going to kind of move into some other areas just to give you some perspective. This would be plus 7, plus 7, plus 7. So if I was thinking about this, like a high schooler might see this as a sequence. So they would be adding 7, and they'd say, oh, it's a sequence, and you add 7. But what we really want to do is figure out what would come next. So we want to know what 4 is, which is actually pretty easy because we could do add 7. But if you look at the ratio, what is it really? It's a multiplication, right? 1 times 7 is 7. 2 times 14. So let me change colors here. 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. 4 times 7, or 21 plus 7, is actually 28. And I can actually figure this out up here. Remember, this is the figure number. The big thing that you have when you set this kind of problem up is you need to have like things on the same side of this fraction bar. So I know 4, so I want to know what this is. So I'll just make a question mark there. And then I'll do what's called cross products, or you may call it cross multiply and divide. So I'm doing 4 times 7, and that's 28. And 1 times the question mark would just be the question mark. So it's just 28, right? So what about 5? Same type of thing. 5 times 7, or 28 plus 7, gives me 35. So that would be 35 here. This is 28. Or I could use the same ratio. Works just fine. And I would be doing 5, because I'm still looking for this, right? Let's call that x. That's a mathy thing to do. And then I would just say 7 times 5 is 35. And 1 times x is x. So the thing we're missing is 35. By the way, this works because 1 times 5 is 5, and 7 times 5 is 35. That's where that comes from. That's why the cross multiplication works. I don't want you to ever think like I'm just going to throw something at you and never explain where it comes from. That's where it comes from. This eraser is like really delayed and weird, which kind of makes it more fun. All right, so we'd go all the way down here. Can't keep erasing. Go all the way down here and it'd be 10. What would we do? Could we continue to go up? We could. Or we could use the ratio. 1/7 is our ratio. So the number we're looking for in figures is 10. So remember, figures on top, so figures need to stay here. And I'll just make this x. So 1 times x is, of course, x. And then 7 times 10 is 70. Or if you'd rather, in this case, what do I do? Multiply 1 times to get 10? Well, 10. And then 7 times 10 would be 70. So that's it. And how do you see it growing? Well, each time it goes up, I'd add 7. So I may put that it adds 7 here. Or I'll say that the ratio is 1 to 7. Or 1 to 7. Or 1 to 7. Why do they have different notations like that? Because people were working on this at different times. Math was going on all over the world. People didn't speak the same language. Google Translate wasn't invented yet. Soon, but not quite. So for the next one, use a double number line to show how many liters of each ingredient to use for different size batches. So this 4 liters of orange juice for 5 liters of soda water. 4, 8, 12, 16, 20, 24. How am I doing this so fast? This is a good time to talk about multiplication tables. If you don't know your multiplication tables, you need to learn them. If you need a suggestion for a plan that would help you use it, by the way, now we're at 5, so each batch is going to be at 5. I have some that I've used. My second grader, who's now a third grader, knew his before he even entered third grade because of the program, and he had a lot of fun doing it. You don't have to be embarrassed, but you do have to learn it, because as things go on, like when you get in high school, and I'm saying this because I taught in high school, it's kind of a bummer to not know it because the math gets much more difficult. Just saying. So the first question says, if someone mixes 36 liters of orange juice and 45 liters of soda water, how many batches would they make? So I'm looking at this batch right here. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if someone uses 400 liters of orange juice, so you can either extend this out to 400, which would take 400 years, or we can use the ratio, right? So the ratio is 4/5. And we're given orange juice. So I'm going to make a little notation to myself that the 4 is OJ and the bottom is soda water, which is seltzer, in case it's not cola. So 4/5. So I'm looking for 400 liters of orange juice. So I'm going to put that there. And then I'm going to do my cross products, right? So 4 times X, and then 5 times 4, 100. I'm just going to put this up here in case you need it. You probably don't. You're smart. Have some faith in yourself. And then I'll just do a quick division here. Well, 4 can't go into 2, but can sure go into 20. 5 times. So that would be nothing. I'd bring down the 0. Well, it can't go in there, but it's 0. And it can't go in there, so it's 0, so it's 500. So X is equal to 500. Look, remember the other way that I showed you? What do I multiply 4 by to get 400? Well, 100, right? And 5 times 100 is 500. So my answer to this one is 500. It's not like super messy, but it's not super clean either, let's say that. And finally, if someone uses 455 liters of soda water, and since this takes forever to erase for some reason, I'm going to just go ahead and say whatever and worry about that, and I'll do this color over here. So I'm going to use my ratio again, 4/5. And remember, this is OJ, and this is soda water. And again, you may not have to write all this down, but you should in the beginning learn to write it down, because once you see it a bunch of times, you'll start to do it, and that's how you build good habits that you can use. So I've got my soda water. It goes down here. Yuck, this is going to be a mess. And then my something OJ. So I'll use cross products here, because I cannot tell you for the life of me what I have to multiply 5 by to get 455. But I can figure it out. So 5x, 455 times 4. That's a gross one, isn't it? 0, 2, 5 times 4 is 22. 2, 4 times 4 is 16, 17, 18. 18, 20. I'm sure there's some historical thing there that I don't know about. There's a reason why I'll teach math and nothing else. So this goes in 3 times. It doesn't go into 1. It goes in 3 times. And 3 times 5 is 15. That leaves 3 hanging down there. Bring down my 2. 5 goes into 32 6 times. 6 times 5 is 30. Bring down my 0. Goes in 4 times. So the answer to this is 364. That's yucky. What else could we have done there? Well, Another one, remember how I talked about how you could just figure out what this is and then apply that here? That might be a good idea. So if I do 455 divided by 5, because the math looks really good here, it doesn't go into 4, it goes here. So 9 times 5 is 45. Bring that down. 5 goes into 5 one time. So it's 91. That's my multiplier. So I just do 4 times 91. Sorry for bringing this over here. That's kind of a terrible strategy. So I'll just do it right here. I'm fighting over what works for a brain and also what looks good on paper or reasonable. 4 times 1 is 4. 9 times 4 is 36. So again, 364. That's where that comes from. Explain the trouble using a double number line diagram to answer the last two questions. It would take forever to write all those out. You just can't extend them long enough. So they are weak in that area. One more, and we're all done. So we're going to try to fill in the rows here. Almonds and raisins, we're making trail mix. Why there's no M&Ms in there? I mean, like, why even bother? So my ratio, of course, is 7 over 5. That's really all we need. If I want to find this, remember almonds are on top, so I'm going to put A down here and R down here, so it's like a pirate, R. So my almonds are at 28, so it'll go up here. And then my raisins are down here, so I'll put X. So I can do cross products here, or I can just think, what do I do to get from here to here? Well, it's 7 times 4, right? Do that same multiplication here. 5 times 4 is 20. That's where that number comes in. Let's do the next one. Down here, still same ratio. Nothing's changed. The only difference is the value I have is in raisins. So that 10 goes down here. So 5 times 2 is 10, and 7 times 2 is 14. So 14 goes right there. If you want to do cross multiplication, you could do 5x equals 70, and doing that division 1. 5 goes into 24 times. So that's where that number comes in. All right, this one's the only super weird one. Weird one incoming, I guess. 7 over 5. But the almonds here is 3.5. What? 3.5? Why? This one can either be cross products, or you might know that half of 7 is 3.5 if you just think about it a little bit. So this is actually times half. So I just need to take half of 5, and half of 5 is, so think about $5. Half of $5 is $2.50, right? So 2.5. Or you can do cross products here, which would be 7x. And then I'll do 3.5 times 5. 5 times 3 is 15, 16, 17. Oh, don't forget decimal. Boom, right there. So then you do 17.5 divided by 7. Get that out of the way. Made a huge mess. So 7 doesn't go into 1. It goes into 17, though. And it goes in twice. 14. 2 times 7 is 14. So subtract 3. I'm going to bring my decimal point up right there. I'm going to bring down this 5. 7 goes into 35 5 times, because 5 times 7 is 35. So that's where that comes from. So 2.5, just like I said. All right, let's do 7. This equals, it's 250 in raisins. Remember, raisins on the bottom. So it goes here. So I can do cross products if I want. 5 times x equals 250 times 7. And some math teacher must have loved making this, because it has all kinds of what you might refer to as annoying multiplication. 0, 5, and 3, 14, 15, 16, 17. 5 does not go into 1. It goes into 17, though, 3 times. 5 times 5 is 25. 0 and 0, bringing that down. 5 goes into 0 times, so 350. Also, you could have thought, oh, I wonder how many times 5 goes into 250. Well, 5 goes into 25 5 times, and then you have that 0, so that would be times 50. So the times 50 here, 7 times 50, 3,500. The last one is actually much easier, thank goodness. The only issue is make sure this number's on the right side, so it's on top, 56. So I can do cross products here. I can do 7x. But you know what? I don't want to do that because it'll take even longer than I want to, because I know 7 times 8 is 56. So 5 times 8 is 40. And that's all you need to do. The big deal is working off the ratio and getting your multiplication tables in order. If your multiplication tables are in good shape, you'll be in good shape when you do this. So hopefully those are something that are well practiced for you.